Hi guys, welcome back. Today we are going to be talking about lesson 4.1 and we're going to spend a couple of days on this because I've found in the past that people have a little bit of trouble with piecewise defined functions. So it says 2 days, we may spend like 2 or 3. But it is in your Springboard book on page 57. That is where we're going to start, so you need that. You need a pen or a pencil. You'll probably want a calculator, and I would even recommend maybe having different colored pens or colored pencils because I'm going to be using a lot of different colors today to show you the different pieces of a piecewise function. Okay, so let's get started. First up, we have that we are going to be able to graph piecewise functions, piecewise-defined functions, and we are going to be able to write the domain and range of functions using interval, inequality, and set notation. Okay, so we're going to be talking a lot about domain and range as well as we move through these next couple of days. So looking at this first example here, it says the graphs of both y equals x minus 2 for x is less than 3 and y equals negative 2x plus 7 for x is greater than or equal to 3 are shown on the same coordinate grid below. Okay, so this right here and this right here, those are basically like limitations or what I'm going to call your how you know where your fence is. Okay, so basically what it's saying is this side or this graph can only happen where x is less than 3. Okay, well, that can only happen then here where x is less than 3. Okay, and then it's saying that this graph here, or this line, can only happen where x is greater than or equal to 3. So that's why this is right here. Okay, now the fence kind of separates those two. Okay, and when it says x is less than or x is greater than 3, that's always going to be a vertical line because it has to go through the x-axis. Okay, and we're going to be talking a lot about that. And I like to use a dotted line or a dashed line to show that fence, but really it's like an imaginary line. Okay. All right, so what I'm going to have you do is describe the graph as completely as possible. So I'll leave you guys a little open-ended question here. Go ahead and describe. All right. Then number 2 says, why is the graph a function? So hopefully you have heard of this before, but this graph is a function because it passes the vertical line test. And basically what that means is that each input or x value has exactly one output or y value. Okay, and it also means that if I were to draw a vertical line anywhere on here, it would pass that, meaning it would not cross through that line more than once. Okay, so that's what your vertical line test is. Now, let's say I had a graph that was just kind of the flip of that. So maybe it looked like this, right? And I went and I go to draw my vertical line test, and this does not, this does not pass a vertical line test because the vertical line would cross through the function at 2 places. Meaning that there would be, for one x value, there are actually 2 y values. Okay, so this would not be a function. Not a function. And this one over here would be, yes, it is a function. Okay, so basically it has to pass the vertical line test in order to be a function. Okay, so we're going to be talking about that a lot. Sometimes I will just put VLT for vertical line test. Okay, and check, it passes. Cool. Alrighty, so in this next one, we're going to try to kind of graph a piecewise function. And this is our first example, okay? So what I'm going to do is tell you guys that, again, whenever you see these inequalities, Those are kind of like your constraints or your limits, and you want to put a fence or a dotted line at that spot. So in this case, it's at 0. Okay, so we draw that in. Then what we're going to do is I would make for each equation, so this one is y equals x squared minus 3, I would make a little table. Okay, and then for this one over here, it's y equals 1/4 x plus 1. And again, I would make a little table. Okay, and we are going to plug in x values that only fall on the correct side of the fence. Okay, so this green one says that x should be less than or equal to 0. So we're going to use numbers that are less than or equal to 0. So we're actually going to use 0 because that's equal to 0. We're going to use -1, and let's use -2. Okay, we just need a few points. So what I'm going to do is plug each of these in to figure out what the y would be. And you can just plug these into your calculator. But if I plug in 0 for x, 0 squared is 0. And then -3, 0 minus 3 is -3. Okay, cool. If I plug in -1, -1 squared is 1. 1 minus 3 is -2. If I plug in -2, -2 squared is 4. 4 minus 3 is 1. So now I'm going to go ahead and plot these points. So I have 0, -3. I have -1, -2. And I have -2, 1. And I might just do one more point just to be safe here to figure out what this graph is going to look like. So if I did one more, -3 squared is 9. 9 minus 3 is 6. Okay, so now I know -3 up 6. So I see that this actually has a somewhat curved line here. Okay, cool. And that is because it's a quadratic function, so it should be in that like U shape. Okay, cool. Moving on, we're going to do the same thing over here, but it is where x is greater than 0. So because it's not equal to 0, we cannot plug in 0, but we can plug in anything greater than. So let's maybe just do 1, 2, and 3. Or maybe 1, 2, and 4 would even be nicer. Okay, so again, we're plugging these in for x. So 1/4 times 1 is 1/4. Plus 1 is 1 and 1/4, or if you want to say it as 5/4. Okay, then plug in 2. 1/4 times 2 is 1/2. Plus 1 is 1.5, or if you want to write it as 3/2, either way. And then 1/4 times 4 is 1. 1 plus 1 is 2. That's why I wanted to do that one because it works out nice. So we have 4, 2. Come on. We have 2 and 1.5 or 1.5. And we have 1 and 5/4 or 1 1/4. Okay. So that should kind of look like this. Whoops. And one thing to note here is I noticed something that is not okay. Okay. So remember that vertical line test that we were just talking about. Well, if we look on our fence here, this is not going to pass the vertical line test because we have 2 points on that line 0, right? So I'm going to go ahead and erase that. And here's what we really need to focus on. Hopefully we remember that less than or equal to or greater than or equal to signs have a closed circle or a solid line when we were graphing inequalities. And less than or greater than have an open circle or a dashed line when we were doing inequalities. So this here has to be an open circle because it just said x is greater than 0. So we cannot close that circle, okay? This one here, x is less than or equal to 0, this one should be a closed circle, okay? So you will have some options on your fences. And your options are that you can have a closed circle and an open circle, one of each, like we did here. That's totally fine. You can have an open circle and another open circle. That's totally fine. Okay? But what you cannot have is what I showed you at first, which would be a closed circle and a closed circle, because that does not pass the vertical line test. So that right there is not allowed. So every time you finish a piecewise function, you should check your fence and make sure it either looks like this first one or the second one, but not this third one. Okay, you cannot have two closed circles on the same fence because, again, that would break this rule here. It wouldn't pass the vertical line test, and the x value would have two y values. Okay. All right, cool. Moving right along. Go ahead and describe as completely as possible that function that we just graphed together, this one here. Okay. All right. Whoops. Sorry about that. Oh no. Wrong way. Okay, so here we go. This is your math term. It says a piecewise defined function is a function that is defined using different rules for different non-overlapping intervals of its domain. So this is how it will usually look right here. And it says the functions in items 1 and 3 are piecewise defined functions. So the two we just did were examples, okay? Piecewise defined functions are written as follows using the function from item 3 as an example. So this is your name of your function, and that could be f of x, g of x, k of x, whatever you want, okay? Then there's a single brace or squiggly line. And then, so it kind of looks like a system of equations like we were doing before. And then there are function rules, and then there are domain restrictions. The domain restrictions are like your fences, okay? That's how you know where your fence is, okay? And then your function rules are what you graph on each side of the fence, okay? So let's try another one here, okay? And again, we're gonna wanna use a table. And it says to complete this table of values and then graph the function. So first thing I want you guys to get into the habit of doing is looking at this domain restriction and making your fence right away. So since it's at -1, we're going to go ahead and do that. And again, I'm only using a dashed line because it's technically like an imaginary line, this fence. Okay, and I'm going to actually outline this here too so that we remember to check our fence so that there aren't two closed circles. Okay, all right, so let's go ahead and look at this now. So -2x minus 2 is only where x is less than -1. So that's going to be these numbers here where x is less than -1. Okay. And then let's use a different color. So x plus 3 is going to be where x is greater than or equal to -1, which would be here. Okay, so again, we can kind of do that blue. You know, the top one's blue, bottom one's green, if you're using colored pencils or colored pens. Okay, so -2x minus 2. Now we're going to plug in those x values. So -2 times -4 is a +8. Minus 2, we should get 6 here. Then -2 times -3 is a +6. Minus 2, we should get a 4 here. And you can be doing this in your calculator. -2 times a -2 is a +4. Minus 2 is a 2. Okay. Then this red one, we can do in red. So we'll plug in -1 and -2x minus 2, so or -2x, -2, sorry about that, times -1 is 2, minus 2 would be 0. Okay. Then let's go ahead and do the greens. And we have, let's start again with the -1. So -1 plus 3 is 2. Then moving on to 0, we're plugging in here. 0 plus 3 is 3. And 1 plus 3, 4. 2 plus 3, 5. So now we're going to go ahead and plot those points in the corresponding color. So -4, +6, way up here. -3, +4. -2, 2. And then we have -1, 0. Now, should that be an open or closed circle if we're graphing this blue one? Okay, hopefully you answered open. Okay, then let's go ahead and green and do the other one. So -1, 2. That should be a closed circle because we're looking here. So we got a closed circle. And then 0, 3, 1, 4, and 2, 5. And we draw our line, and we draw our other line, and that is what your piecewise defined function looks like. Okay? Now, please remember we have a second day on this, and we will do some extra practice with that. So if you have any questions, let me know, but we will definitely be doing quite a bit more practice with these. Okay? Alrighty, have a good one. Bye-bye.